This video is about the Heap Sort and maxheapify especially. Before that, a correction in the previous video. Even if there are k levels and all the levels are complete, then also it is a heap. Okay, so Heap Sort consists of three functions. The first function is the Heap Sort. It is the main function where all the code for sorting lies. There we will see in the next videos. Then build heap, another function to make the heap of the elements whatever we have in the beginning of the code. Then maxheapify, the function to make sure at every step that the structural property of the heap is satisfied. So in this video we will learn about this maxheapify function, in which we will make sure that the every node satisfies the structural property. What is the structural property? Either it should be a min heap or a max heap. Since it is a max heap, we will make sure that at every node it is a max heap or not. Some other variables and functions. Heap size of AR. AR is an array. This is a variable, not a function, that returns the number of elements of the array that take part in the heap building. There are particular, out of 10 we may be including 7 variables to make the heap, so heap size will be 7. Whereas length of AR, this is a function. Here AR is the array. It is a function that returns the array length, that is length of this array. So if there are 10 elements in total, then the array will length of AR will return 10, and if 7 take part in participating, as said earlier, this will return 7. So let us see how to make a max heap. Convert this tree into a max heap. We have two hints here. First is we have to try from top, next is we have to try from bottom. So if we try this 89, 100, 73, so 100 is maximum, so here we have to write here 100 and here 73, because these two will get exchanged. 100 is the maximum. We are making the max heap where the parent node is greater than its children node, so we just swap these values. Again here 73 minus 137, this is fine. This thing is fine. Here 89, 3, 120, this is not fine. Here again we have to change it as 120, and this will be 89, 89, 81, 11, it is fine. Like 89 is greater than this two, and here 3, 49, 25, this is not fine. Here we have to change it 49, here 3, then everything is fine. No, here you see this is minus 1, this is 0, this thing remains. Like this is minimum, this is maximum. So we have trying from top did not manage, means did not make the whole as a max heap, so we have to try it from bottom. So again make the tree here this side. 73, 89, 100, 3, 120, minus 1, 37, 49, 25, 81, 11, 0. So we have trying from top did not suffice, so now trying from bottom. These leaf nodes don't have any children nodes, therefore we don't have to check for these nodes. Starting from this node, which is the last one, means the array is like this in this order, so this is the last element which has a child. So minus 1, 0, here we have to check, make it 0, here minus 1, 100, 0, 37, it is fine here. Then jumping to its previous element, that is 120, 120, 81, 11, yes, it is fine. Jumping to the previous thing, this has to make it 49, this has to be 3. then its previous element is 100, 37, then its previous that time I don't have to check here. So 100 and then its previous element 89, 49, 120. No, not correct. We have to make it like this, swap, and then this index was checked, then its previous element 73, not correct, 73 here, 120. So my final array must look like 120, 73, 100, 49, 89, 0, 37, 3, 25, 81, 11 minus 1. So doing maxheap for one time won't guarantee that we will get the sorted array. We will only get the highest element at the first index because it is the maxheap. If it was minheap, then we will get the minimum element at the first index. What we do in heap sort is, this is the this was the maxheap. So we got the greatest element at the first index. We will swap it with the last element because its real position is at the last. Since it is the greatest element, we will swap it, make it 120, here minus 1. Then we will consider n minus 1 elements. Sorry. Then we will consider n minus 1 elements. Again we will do maxheapify so that we will get the maximum element amongst this. That is, we will get the second